but we've got a UNO thread in there. We've got a 3/4 UNO port to a 10mm metric heavy fitting, or what we call an S fitting. And the same thing here, we've actually got a 3/4 UNO port to a 3/8 BSP thread, because these valves have 3/8 BSP threads, but here we've got a light metric with a 3/8 parallel port. So this port is called a UNO port. So what gives it away is you've got a thread down deeper, but then before the thread starts there's this actual conical section that starts wide and then narrows down, and then the thread starts. And it's designed to house this O-ring. And the purpose of this, if you see, as I rotate this nut, you'll actually see it's pushing the O-ring up. Alright? So the beauty and the clever design of these adapters is that you actually screw them in with a nut as far back as you can go until you get the position you want, finger tight, and then you then lock this nut up. And as you lock this nut up, you're actually forcing that O-ring into that taper. So it's the O-ring's not only sealing on the external part of the taper, but it's also sealing on this internal smooth section there that's thread free. So nut all the way back, screw it in as far as you can. If you just can't get the orientation you want, if by hand you can't go all the way around, you're almost there but you just can't do it, it's more than acceptable to go back and then lock it up there. There's enough of a smooth non-threaded section to be able to do that. That's the beauty of adapters. So if we were to lock that up, that would also still work and seal okay, because if I pull that out, that O-ring is still in the smooth section. The thread starts there. So we're still very acceptable. The other side's exactly the same. So I've just removed it. So there's that smooth section that's thread free. And as you force this down and then you lock this nut up, all that nut is doing is actually pushing that O-ring deeper and deeper into that taper. So as that O-ring gets forced into the taper, it's obviously made to go smaller, and as it's made to go smaller, the outside of the O-ring seals on this taper and the inside of the O-ring seals on this smooth face here. You'd be surprised how many machines stop working because of literally a 20-cent O-ring. Without O-rings, there would be no hydraulics. They are so important. You know, such a simple design, but so important. The other important item that's really also important is the material the O-ring is made from, because O-rings are made in lots of different materials: natural rubber, neoprene, nitrile, and another more exotic product, which I don't remember right now, but they're also made in different hardnesses as well. So for hydraulics, generally you need something called 90 Duro, so it's actually harder than most standard O-rings that you might buy at the automotive store that are used in automotive applications where oil pressures are much lower than hydraulic pressures. So this is quite a hard O-ring. So I just wanted to make that really clear. It's not just any old O-ring that'll go in here. It's got to be a certain hardness, it's got to be resistant to the temperatures and the oil. It needs to be a certain diameter on the inside, and it needs to be a certain cross-section. If you get all those right, you won't have oil leaks and everything will work properly.